So one of the hardest things to do in my life is when someone hits me up on Twitter and says, hey, you probably don't know me, but I would like you to come speak at my conference. And me, being that guy, says, yeah, sure, why not? And then a few months later, they hit me up and they say, remember that conference that you said you were going to speak at? And I'm like, no. And they're like, yeah, we need a title. So Sasha did all these things, and I said, all right, I'll get you. So today we're going to think about reimagining continuous integration, delivery, deployment, whatever. And that is the focus here. And before I get into this talk, I really want to say that the ideas that I am going to share with you over the next few minutes are ideas. There might be some code. I'm not going to show it to you. But really, I want to share different ways of thinking about this whole continuous integration, delivery, deployment, whatever. So this is me. I like big pictures of myself. I always do this, and I just want to introduce myself. My name is Bryan Liles. I am a senior staff engineer at VMware. The reason I use my title is because I am actually the highest ranked employee of African descent at VMware. So guess what? Badge of honor. And then also, I've been writing code for a really long time. This will be my 25th, 26th, one of those professional years. So I've been doing this for like a quarter century. And I just like senior staff engineer. It sounds just pretentious enough that I can actually say, no, that's just something they gave me. But really what it is I'm an alliteration person, celebrating the hip hop culture. Whenever you speak on stage, wear a nice pair of shoes. Look at these new Jordans. I love cars, I like computers, and I like creating a better world. And then I also like talking about software I wrote. And the reason I do this is because my employer would be like, Bryan, you got on stage, you got to talk about the software you wrote. So I work at VMware by the way of the Heptio acquisition that happened at the end of 2018. And one of the things that we had is 2/3 of the founders of Kubernetes. So all my work is literally Kubernetes. So I was like, well, why don't I write this thing to help you figure out what's going wrong in Kubernetes? And that's what this Octant thing is. This is not what the talk is about. So let's get into this. So as the slide says, I've been using CI/CD systems for a long time. Like, when I remember starting, there was not Jenkins. There was something else. Does anyone know what it was called? Yes, Hudson. I heard some like weird things from over here, but yes, Hudson. Hudson was a thing. Actually, Hudson, and then things like, remember cruise control? Right on, ThoughtWorkers in the house, yep, yeah, right. So I've been using it for a little while. And come to find out, I'm like, I've heard everything. But when I was working at Redacted, an engineer came to me and said, Bryan, we can't get our app to deploy. We ran Jenkins pipeline 91, and it fails with no output. And this person said it to me with no hint of irony. And I'm like, what is going on? And then I was thinking, did they really mess up 90 times to get to 91? And this person was serious. Their actual deployment was running this opaque thing called Jenkins Pipeline 91. And at that moment, I realized, there's got to be a better way. So what this talk is about is ideas about a better way. I've been thinking about this idea for a little bit of time. And then I talked to my old boss, but now almost equal, he's still above me, Joe Beta, about, hey, I think I can flip the world upside down if I get these ideas out there. And he's like, yeah, whatever, because he was busy. But then I was like, no, this will be cool. And he's like, I'll listen to you this time. And then he went off to Spring One and did a talk about what I was talking about. So I know that there's some value in this, but understand what I'm talking about here is I work in an R&D group. This is more R than D. So just put that out there. So we're going to start off with one little square on the slide, And the good thing is it's not, you don't have to read it. I want you to see shapes if you care to look. If not, I'll just describe it to you. But really, this is how businesses work. We develop, and then we do continuous integration, and I'll talk about what that actually is. And then we do continuous delivery because we all read the book, or maybe your boss read the book and said you need to do continuous delivery. And then, but you know what? That's not good enough because like our industry, we like to take good things and then we like to combine them to like worse things. So what we did here is we just created CI/CD. So now we have this thing called CI/CD, whatever. And now we'll take our CI/CD and we'll move it to prod. Problem solved. Well, hold on here. We realize that whenever we move software like this, there's lots of bugs that come in. So maybe we should change this a little bit. So we'll add more CI/CD, and we'll have a test environment in there, and then we'll move it to prod. All right. And then someone's like, well, test is cool, but what if I want users to be able to see it? All right, well, we'll throw a UAT environment in there too. And I can actually do this all day, and I think I can come up with like 20 environment names, but you get the point here. What we've done is we've taken these things, these ideas that should be simple, these ideas of continuous integration and continuous delivery, and we just combine them into something that means nothing. And if it means nothing, guess what we can do? We can just make it up as we go along, as we do. So, when I was a kid, I'm tall now. I grew like 5 inches when I turned 18, my first year in college. I was a skinny kid, and funny thing is, believe it or not, I could not play basketball. So, and I wasn't fast. I've always been blind as a bat, so baseball wasn't a thing. So I did something else when I was a kid. I played video games. And not just any video games, because I am over 40, protected class in multiple categories right now. A lot of old people in here. I liked old CGA games. Like or this was an EGA game. When this game came out, it was an EGA. It was 16 colors, and I'm like, what is going on? It's my favorite game of all times. It was renamed, but I will never call it that. But I wanted to take that feeling that I had when I was a kid, and I wanted to somehow bring it to the stage. So this game was renamed to, all right, I'm the biggest nerd in here. It was renamed to Quest for Glory, so you want to be a hero. So let's change it. We're nerds. We're going to deploy an app. So as you can see, I like boxes with words in them. This is about my creative ability right here when it comes to Keynote or PowerPoint. So you're going to get a lot of this. So we have an app, and we have prod, as we do whenever we are doing business things. And some smart people were saying, well, we should have a delivery process to get the app to prod. Makes sense. And then, well, we probably want a source code management thing like Git. So we'll put that in there too. And our delivery process will now talk to our source code management piece. But now, well, we read the book, the continuous delivery book, and we're going to do integration. And we're going to integrate frequently. And what we're going to do is we're going to do one of 3 things. We're going to produce a repository, a registry, or a tag. And you're saying, what? Well, we're going to create, like, if we're doing like Java, we're going to take that thing up, we're going to bundle it up in a container, and we're going to put it in a repository. Or if we're doing like Docker stuff, we're going to take that thing, we're going to run Docker build, and we're going to put it in a registry. Or we're just going to say, you know what, git tag. And then we might have more than one environment. But we're smarter than that now. So now we might have like PR environments. So this is what we are trying to do. Abstract. Like, if you actually don't think this is what you do, please raise your hand. Right. This captures, I don't like you. So that's not going to work. And just for the audio, Dave Farley raised his hand and said he does not do this. So yeah, that's all right. So I was thinking, yeah, so this is what I'm trying to capture. And not trying to capture like every case, but the essence of this problem. Because what I'm trying to do is I'm trying to rebuild this. And then I had some thoughts about this. So everything that I just showed is possible today. People are doing this right now. And if you can't do this, or you're doing way more, maybe you should rethink about how complicated your stack is. The complexity created by ops is not transferred to the dev teams linearly. I don't know, it's like maybe it might be a power law involved in there, just to tell you the truth. This is not even exponential. This is like a power law. We're going up at the end. And then always, and then this whole thing about the PRs is, I like to tell my users and people that I work with is that you have prod, you have test, but do you deploy your PRs? And they're like, no, why would I'm like, why would you not? There's nothing worse than getting some code to review, and maybe it's 100 lines. I want to be able to click on it if it's a web app. So let's go back into what I was talking about earlier. So we have this app to our Git repository. That makes sense. App, we're developing in a branch, and then we just commit it to our repository. And this is important. I just want to get this out of the way. And then we have our integration process. It says, oh, Git repository changed. Let me go do my thing. And what is my thing? Repository registry tag. And then, so delivery process is like, well, I want to get in on this too. And so it's listening for repository registries and tags, or maybe something else, and then it pushes it to the prod. Just wanted to get that out of there. So here comes the speculative part of my talk. So who likes blocks? No one even asked what kind of blocks. I like blocks. Legos. Legos are nice. We will talk about that in a second. So what if we just reimagined our whole deployment thing as a block? And this is my interpretation of a Lego. Keynote doesn't really give you a lot of options there. So pretend that you squinted and you're looking at it from, well, it doesn't really matter what angle. You're just looking at it squinting. So just imagine that. But let me get into this whole thing about Legos. So everyone likes Legos, especially if you're a parent and it's dark and you have kids. Love Legos. But here's a crazy thing about Legos. This is where the analogy comes in. So we have Legos. Anyone know what these are? Duplo. They're Duplo box. Who makes Duplo box? Lego. And what are they for? Kids. And here's the best thing. They are bigger versions of the Legos that we like. So maybe we could have bigger blocks that could actually take up the space of smaller blocks. I don't know, onto something here. And then we have this. This is a Bugatti Chiron, and I do not own one of these. I tried, but $3 million for a car is actually out of my budget, so that did not work out. But this is Technics. Who makes Technics? Lego. And what's the best part about Technics? They work with Legos, but they're smaller and they're more technical, and they allowed you to build things like race cars and all sorts of other crazy things. And one more. What's this? Mindstorm, also built by Lego. And the thing about this, these add smarts to our Legos, so now we can automate and make our Legos move autonomously. And 2 more Lego pictures. What's this one? A Millennium Falcon made out of Legos. This is like, I don't have the patience to build something like this. But the analogy here is, what if I could build a system and we had Legos, and I could hand you a Millennium Falcon, and you could decide that you don't like that radar dish and you want an orange flag. Well, what would you do if you have Legos? You would take it off and put it on. And now you have your own creation. I don't know why you would do that, but you can do that. Important to my analogy. And then we have my final picture of Legos. This is Voltron. And neat thing about Voltron, this is actually a couple of things. We built something very complex with Legos, but you notice that we have the 5 lines that come together to create Voltron. So we have these complicated Voltron lines that can actually combine together and somehow make a sword. And if you think about this, now we have all that complexity combined in one robot that is here to protect the universe. Think about that. So now my Legos has parts to it. So now we've taken our analogy of maybe we started with the Duplo block, and now we have regular Legos inside of it, and we're going to call that our deploy. So let's think of what a block could be in this space. Well, we can have integration, our integration block. And it's just really simple. Build applications. If you need your application to be built, if you use a language that actually has to be built, you can run tests, you can create an artifact, think about it, and you integrate in a block. Which means that in theory, you could actually have one way, you could have a Jenkins build block, and you could have what's another CI tool? Circle CI. Does that person work for Circle? All right, just making sure, because I know they're here. But you could actually swap it out with Circle. It's like what we want to do in programming all the time. This is like the best type of polymorphism that there is. You just call it, and it does something, and you know it's going to come out. But back to this integration. So what would be inside of integration? So now we're at a Lego. Now we're at the Technic side. And what I realized is that just thinking about integration just in general, and this is really speculative, and I'm sure we could think of more, but you could have a webhook trigger, listen to GitHub to actually say that I need to be a build, have a workflow that actually runs the build, and then maybe you could have a Slack message as a notification or an email, or if you're in an environment where you actually need to have an approval to create builds, you could actually send out an approval from your integration block. Then we have our delivery process. What's it do? It deploys an application. Maybe it solicits approvals because you might need a VP to say that you have to deploy to an environment. I used to work for a bank, and if it was during the holidays, you had to have a VP to push. And maybe it runs data migrations. I don't know. It can do a lot of things. Delivery is complex. So our delivery process, oh, wait a second. It has triggers. It has workflow, notification, and approvals. Well, hold on. These two things look alike. And I'm going to say that this is not the reason people conflate CI and CD, but when you break them down to the base components of how you would actually build these systems, guess what? You can use the same systems to build these. So I have a lot more time here, so I'm going to go into a little deeper. So webhook triggers. And these, I'm going to show the reasons why I picked these four. These are not the only four things you could pick, but these are a good starting step. So webhook triggers. Someone or something somewhere says it's time to get to work. And you know what? It doesn't have to be just webhooks. In the Argo project from Intuit, they actually have a lot more things that you could have. We could actually trigger something from Slack or PubSub or streams. Lots of ways that we can make things start. And then we have a workflow, do something in order. And this is actually the most proudest I've ever been in Keynote, so just pay attention to what's getting ready to happen here. So you have a workflow, and a workflow has tasks. And inside of a task, there might be steps, multiple steps, it doesn't matter, and number of steps. And then what we can also do is say that we can combine these steps to make a pipeline. So we can have multiple steps that run together to make a pipeline. And the neat part about this is like a pattern that you can do with Google's Tecton, and you can do with Argo, and actually you can do with a few other things too, where we have 3 tasks that start all at the same time, pretend that the workflow goes from the top to the bottom. And the first 2 will actually run, and then the one below that one will wait until those 2 are done, kind of like a diamond pattern or something like that. And then when all the tasks at the bottom are done, pipeline is complete. Kind of neat idea. And what can be task? So I have a little bit of examples, to show you where I'm thinking about. But think about it at the level of deploy an application, run database migrations, wait for an approval, test an image, things like that. And so you have notifications. Notifications are pretty easy. You just notify something. And then you have an approval. Wait for something or verify something can happen. So we still need one more thing. And I know someone in the back of the room is thinking, come on, Bryan, you forgot GitOps. And I didn't forget it. I just decided to put it here rather than at the beginning. And if you have an application and we're storing that in Git, well, why not install our configurations in Git too? I mean, this is like a common pattern right now. So I wanted to add it to this. This is very important. So now we have all the ingredients. So let's look at our new fancy drawing of how our deployment should look. So now I've added config here. And now when config changes or the app changes, we can start integrating. Interesting. So let's actually change the conversation a little bit. What do you think of when I say PaaS? And I'm going to play MindReader. And Heroku, yeah, they're a pretty big one. Cloud Foundry, I'm sorry about that one. That's the best I could do. That does say Cloud Foundry. And I'm like, they're like my coworkers now, so I really feel bad about that. Deis. But I'm like, you know what? I don't think of any of that. I think that I have an app, and I kick it, and it gets into PaaS, and it shows up. Git push Heroku master, git push Deis master, CF push. That's what I think of a PaaS. What's inside of a PaaS is their business. But I'm like, hold on. We can do better than that. Why don't we take our deploy, and we'll just strike out the name, and we'll call it a composable PaaS. So all the things that are inside of a PaaS, exploding and running your app, setting up networking. We can actually run CI and CD as part of our build pipeline and pushing to the PaaS. Why don't we make something called a composable PaaS? And what is a composable PaaS? Well, it's really just all the things that you would think of inside of your PaaS, outside of your PaaS. It's like an Audi instead of an innie. I don't know. Yeah, so this is where I come from. And I know people are like, Kubernetes, Kubernetes, Kubernetes. I literally work with people who created Kubernetes. So guess what I get paid to do? Talking about Kubernetes. And the neat thing about Kubernetes is that it's a platform for building platforms. And this is an interesting saying because it has controversy, because I say it, and then Joe Beda says it, one of the founders of Kubernetes, and then Kelsey Hightower says it, you know, just international rock star, and they debate who said it first. And you know what? I think about, I don't care who said it first. I'm saying it best, and I'm saying it now. So I invented it. So now, how do we do this with Kubernetes? Well, this is what we can do. Take our picture, and pay attention, lower right-hand corner for the slow people. We just replace the environment with a namespace. Now we just deploy to a namespace and a cluster. So if you think, wow, Bryan, you're really simplifying this. Well, here's the point. The whole point of this talk is that we have conflated CI and CD to things that are unattainable to people. Why don't we reduce these topics to what they are and make them approachable and reachable by our ops teams, our development teams, and even something you can explain to your execs while you're flying on their private jet to whatever island they own. I don't know. So back to this. So we have this integration block. What we can do is we can replace these words with things that exist in Kubernetes. And this is actually where this talk could be like an hour, where I could explain how Tecton triggers or Tecton pipelines work. But understand this. Project Tecton from Google allows you to receive that something happened, and then it allows you to do things. And then you can actually take that thing that allows you to do things, and you can send out notifications and approvals. And just because I wanted to be fair and show that I really love Google no more than anyone else, Intuit and Argo, you can do the same thing with that. And so, yeah, so here's the part of the talk where you're going to hate me if you work for Spinnaker or Concourse or Jenkins. So where is Jenkins or Spinnaker or Concourse? Well, here's the problem. And in my world, the cloud native world, the Kubernetes world, the world where we are using other people's computers for good or bad, if I'm already running a platform for platforms, why would I bring another engine in whenever I have a facility that can actually just run random workloads? Don't need Jenkins or Spinnaker or Concourse. And not saying that we did not need them to get there, because Jenkins really put in front of us, what CI could look like. Spinnaker actually took it one step further and said, this whole idea of pipelines, I can show you how to visualize them. And Concourse and its Fly CLI, it's really good stuff. We should take the lessons from them, but we should leave that old tech behind. It's like people who drive electric cars. You're like, I'm leaving gasoline cars behind. And maybe that's a good thing. I just bought a car and it gets 14 miles to the gallon. I think that's a good thing. And when I turn it on, I can wake every neighbor up on my block. I think that's a good thing, but I'm not a good example here. We should actually be taking these ideas that we learned from before and using those to make even better ideas. So I'm not saying we should just throw them away, but we should say, you know what, it's been nice. It's not you, it's me. And we should move on. So, I know I said continuous at the beginning of this talk. So the idea here is that we take these ideas of these blocks and that we combine from Duplo to Legos to Technics. And then we apply the continuous piece, which is the Lego automation piece. And yes, 5 more minutes. And so Bryan, what's the point here? The point is that I think we are ripe for reinventing the term of PaaS. And PaaS does not have to be other people's software or something you can't touch. PaaS can be something that you can build and ship to a platform where it can run it just like it was native, i.e. Kubernetes. So why aren't we doing this today? Well, here's the reality. I only can be awake for like 13, 14 hours a day, and I have a lot of things to do, so I haven't had time to write it yet. But I've had lots of time to think about it. And why else are we doing this? Because really, it's easier when everyone doesn't have the great tools. We need people to stand out and go out front and figure out what's possible. So what should we be doing now? Well, this is what I'm doing. I'm researching this idea behind blocks, because what I think I can do is I can actually boil down what we have now in all of our systems to this thing called CI and this thing called CD, or this thing called, what about SNCs out there? What about automated container testing? What about if we wanted to do things like feature flags? We should be able to boil that down into this app, and we should be able to build it and just push that whole thing. We've proven that we can do these kinds of things. And the last item is, wait for me to build it for you. I don't know. I'm working on it. But really what I'm trying to say here is that we really need to think different about our tools. The status quo got us to where we are, but it won't get us to where we need to be. And we should be thinking bigger, and we should be thinking different. So, what about security? Well, I mentioned SNCC, and there's Aqua, and there's a few other companies that are doing this. Well, I don't know. I think what we should be building is systems where we can actually put those blocks where they're needed. And then if we wanted to swap SNCC out for Aqua, we just take that whole piece out. And the problem we have right now is, no offense to Jenkins, but if you've written a pipeline or you've done all this groovy stuff, how do you change it? Well, you get the person who's the expert, and they change it. And it's funny, I had a conversation in Dublin. No, I was not in Dublin next month. Lisbon last month, and I was complaining about Groovy, and just lo and behold, the dude who invented Groovy was sitting next to me. And I wish he would have said something before I basically talked about his mother. And we shouldn't have to be in that situation. We should be able to build systems. We have figured out package management. We have figured out container management. We figured out how to run those things at scale. Let's take those ideas and move them to this space, this delivery space. So, final thoughts. And I know I didn't talk about this, but I figured this is a good place to throw it in. Rollbacks don't work. Just get that out of your mind. If you change data and you want to change it back, it doesn't work. You got to figure out how to move forward. It's like bad relationships. You can never go back. It won't be the same. And then the second point, I'm sorry. And the second point is, this is all opinion and not a judgment on your bad decisions. I'm not judging anything. And then really, the blocks I propose are the only start. And the point here is that we got to think more about composability in our systems. Nothing exists in a vacuum. So whenever you see someone selling a SaaS, or you see someone selling this product, and you're like, well, how does it fit in my other thing? We're like, well, write a whole bunch of PowerShell. No, not doing any of that. It should just slot in. And then also, we all move forward together. We can't move forward by ourselves. So this will be the last slide, because like I said, this is a research talk. I was not going to go code heavy and show you all a whole bunch of things. I just wanted to make you think that there's a better solution that I might or might not be writing right now. And I want to leave with one last thing, Waving Ralph. And that was 84 slides, and I'm done.
All right, so while y'all are coming up, we're going to start off with the first question. Again, you should all be familiar with this, but what are the challenges that you're currently facing around building composable modular systems about building PaaS?
So I would say the very first challenge that I want to bring up is documentation, because how do we get all of these composable things to all be documented in the same way? So I think that's a really big question in there.
Why is Heidi Waterhouse not up here? All right, while Heidi's coming, anybody else with challenges?
Keeping small pieces small.
Before Heidi speaks. So one of the biggest problems now is that the status quo, people don't understand CI or CD as a thing unless you really work on it. So people don't want to change it. So one of the biggest issues that we're going to have right now is trying to change how people are thinking about this.
All right, I have a feeling about documentation because you know me. I always have a feeling about documentation. I think the idea of composable elements is important to understand in the context of documentation, because I think we need to be thinking about how it is the next person is going to understand the promises that we are making implicit in our composable objects. Just like Lego has a standard that you can say that the stud is this many millimeters, and if I want to make something that interacts with Lego, I know what size it is. I think all of the things that we make need to make their APIs as, like, not necessarily real APIs, but APIs specific and documented, and that's the first thing that we have to do to make it work.
+1.
A great keynote, thank you. The humor really helps. And this is going to contrast. Dave Farley mentioned in the morning, Unix has come up, Unix philosophy has come up. We have failed ourselves. Where are the simple pipes? It's called a CD pipeline. Where are the simple pieces? Where are the tools that do one thing and do it well? I mean, 15 years down the line, this stuff is hard. And we do it for a living. I mean, it's a somber realization for me. Thanks for giving me that epiphany. We have made CD hard for ourselves, let alone the product owners and the other people who are not technologists. We have betrayed the Unix philosophy. Let's roll up our sleeves and get back to action.
I think one of the biggest challenges is that the methods we use to compose these things all suck. I mean, YAML. You know, I mean, I've seen CI pipelines that were 3,000 lines of YAML, and that's composable, but it sucks.
I'm more directive than most people when it comes to continuous delivery. When we wrote the continuous delivery book and we said, you know, there's a chapter about the commit stage, we meant have a commit stage. And when we said there's an acceptance test stage, or at least I meant, have an acceptance test stage. We were specific. The idea of a deployment pipeline, to my mind, is not a general workflow for building stuff. And if you know, I think there's more depth to the model than that. And what that gives you, if you apply that kind of thinking, is a model for abstraction. It means that you can start abstracting these stages and be more specific about the nature of the interface between those stages and the information that they need to compute. I've kind of built a lightweight version of what you're talking about, I think, for a company that I worked for a little while ago. We built a thing that was kind of a template. We kind of continuous delivery as a service. We kind of built a template of deployment pipelines that people could then customize and plug in their own bits and pieces. It wasn't hugely sophisticated, but I think thinking about this as a generalized, you know, build anything in any kind of wacky way is not enough. I think there are some specific things that you can kind of nail down and you can kind of model, and that makes this sort of thing possible.
So yes, you're 100% correct. And the reason this and the reason this idea came about is because a lot of this stuff was hard and people didn't understand how to model it correctly. So what we were trying to do was give people a great first step. And then whenever you decided that you didn't need this piece, you pull it out. It's gone.
one of my frustrations, we were talking about this in the break earlier on, Ken and I. One of my frustrations is that I think that the software in this space should be more opinionated. Nearly all of the continuous delivery tools don't give you a model for what they should be doing, and I think they should. I was a bit disappointed. Go, the ThoughtWorks continuous delivery tool was a nice tool. I was a little bit disappointed in it. It wasn't more opinionated. I think it should have been saying, out of the box, it should have given you, what would work. And then if you wanted to tailor it and customize it beyond that, fine. But it would, out of the box, it would work. One of the things that I like about Gradle, if you take the opinions of the Gradle developers, you can have a build system in one line. Why not do that? And you can override it and customize it as much as you like, but you can just take their opinions and it just works.
So I think that we have a continual tension between over-optimizing early, and there is no fix as permanent as a temporary fix. So if we say, ask me about my PVC standing desk 4 years later. It works great. But if we say we just wanted to get people into this and we don't give them the opinionated framework, then what we're actually setting people up for is a chaos of complexity. And I want us to be talking as a community about what best practices we would put in a tool. Even if we don't have that one tool, what do we think should go in it? And the answer is always going to be, it depends, but we can still say, it depends. Are you big? Are you little? Are you doing data? Are you doing something else?
So I think that's a natural segue, actually. What are some of the things that y'all are doing as we talk about what successes you've had in this area? What are some of those successful little bits that have gone into this?
Well, I think that the newish managed delivery initiative that's in the Spinnaker community being implemented or being incubated at Netflix is an example of trying to do this sort of thing in Spinnaker, which is, yes, a flawed and sprawling platform. But it's really interesting because the point of managed delivery is to do what you were talking about, which is kind of alleviate a lot of the overhead that comes with being an application owner, because like 85% of that stuff is actually dialed, and there are best practices around it. So we kind of just need to figure out as a community, how can we stop just saying that we're better together and figure out a way to come together around some standards that we're all willing to build against and all willing to codify those best practices against. So we just need to pick one. And maybe it could be managed delivery. We'll see.
This probably belongs more in the next question, but I'll pick up on that standard. So we are all here, many of the vendors are here. Can we standardize some of these things? Why is moving an artifact from stage A to stage B not standardized? Right. Why is firing up or getting a container, I don't even care if it's Docker or whatever, from here to there not standardized? Why is it solved 5 different ways? We're never going to get to the Unix philosophy if we all have different YAML files.
So I feel like Kubernetes at its core actually solves that problem and the problem of like, what are my contracts really, really well, but it doesn't give us a hook to enforce them with. From my perspective as a designer, if you look at what a service is and a deployment is and a namespace is and a config map is and all those pieces, the whole idea is that you can pull out the things that change from environment to environment and make those part of the context that your deployment is running in. And so you have this ability to rubber stamp out these namespaces that are the different contexts that your software is going to be running in. And then when you do a deployment, it's the same byte for byte when you move it from namespace A to namespace B, and your pipeline can do that for you.
So there are people out there trying to solve this problem at a what should we do, best practices, and I can think of one off the top of my head. So Linux Foundation, for better or for worse, has their continuous delivery foundation. But there's some good ideas coming from that group, and I know Spinnaker is definitely well involved. I'm involved in other parts of that, but I think that what we need to do is we need to think about what best practices are, and we can't just have them and say that we need to have them. People who have them, get up on stage like I did. I only shared like a tiny little bit of an idea that I had, but I'm only trying to get you to think. Now what I want someone else to do is to say, you know what, Bryan, you were so wrong, and I'm going to be like, how? And you're going to tell me, and I'm going to be like, yes, that's what I got out of you. That was the whole point of that talk.
Dave's about to say how you're wrong.
I want to tell Bryan how he was so wrong. So I agree with the principle. But I think you solve this problem the way that we solve any other problem, is that you model the problem domain. All of the conversation that I'm hearing, we're talking about it from the bottom-up technicalities. You don't solve this problem this way. You think about it from the point of view of user. In this case, the user might be a software development team, but that's the problem that you're going to model. So what are the things that you need to do? How do you think about that? One of the things that frustrates me is that all of the build management systems that you're talking about, Spinnaker, CI, all those things, they think about builds. I'm not interested in builds. I'm interested in ideas, changes going into production. I'd like to be able to trace those. I'd like to be able to model things differently and think about these things. And I think if you get that abstraction right, what you're talking about, what CDF is talking about, becomes easier. And that's the way in, not doing it from the bottom up. It's not about. You've got to do the plumbing, but first you've got to get the problem, the domain language, the language of the problem domain correct to establish the right levels of abstraction.
So I kind of want to throw a little monkey wrench in this because I like the idea of standardizing things and like coming up with a set of best practices and all that. But like everything that we're talking about, composability and like you plug and play like different things that have slightly different functions, but they all play happily together. And then we have a common set of standards and all of that. And this has been done before. In a domain where the barrier to entry is much higher and the barrier to change is much higher, and it's called USB. And that, I mean, we all still have drawers full of different USB cables now, right? So like in a space where it's much easier to make those changes, which is software, where there's no physical equipment that you actually have to do it, I don't have the faith that we're going to ever get there when we can't do it in a physical space where we actually have to ship new cables. I don't know, it's just, I've never seen it actually work even in a place where we have to build something physically.
You know, as an old school Unix sysadmin, I remember the single-purpose composable tools, but I also remember the vast sprawling shell scripts that we wrote to combine those things together. And I think now I see a similar sort of composability starting to emerge in CI, where the abstractions are Docker and YAML. And as much as we might hate Docker and YAML, I've got a reference implementation of exactly what Bryan talked about today, and it's 100 lines of YAML in GitHub Actions and like 5 single-purpose Docker containers. And I would argue probably any day that this is better than my 400-line sprawling shell script of composable single-purpose tools.
I just wanted to, kind of continue, build up on what you said, and I've been coming to the XKCD on standards a lot lately. How do we have 14 standards? This is crazy. We should have one common standard. Okay, now we have 15 standards, so I think this is kind of how it works.
I think for me, it makes me think of like the fact that usability beats best practices and standards every single time, right? It's like everybody will walk across the corner of the sidewalk even though it's not paved if it's more convenient, right? And like Slack doesn't get to dominating the universe by following best practices or implementing a standard, right? It's just ease of access. It's the easiest option, and that will win 99% of the time.
So I think we're on to the next question, which is, again, if you had a magic wand, if you could change something, what would you like to see in the next 2 to 5 years?
I would say as we try to figure out what we were just talking about, I would really like to see, like, kind of, you were talking about putting, can't see out of the corner of my eye, about putting together like the problem description on the higher level, and I think a lot of the problems that we're dealing with are actually cultural problems around what it actually feels like to do a digital transformation, what it feels like to inherit a really broken Jenkins script and the person who wrote it is dead and gone or whatever, right? And you have to fix it. So I think like I would like to see us come together. So maybe we don't have to collaborate as much on best practices specifically, but if we can collaborate on what are the cultural problems that we're trying to solve, I think that would help a lot.
What I would like to see, and this is again playing back on the culture thing, is if we can get, maybe there's more money to be made in simplifying the YAML files, and all these vendors will keep hammering away the YAML files. no offense to Spinnaker or whoever, until there's all the last dollars are squeezed out of that, and then maybe we'll fall into standards. My hope would be that we kind of fall headlong into it. All of you all get together and say, building an artifact is not, we're not going to invent yet another way. Specifying my pipeline, we're not going to invent yet another way. There's other ways to make money. No offense to anybody. Go ahead and make your money, but as a customer of yours, I don't want to learn 17 different flavors of YAML that ultimately are Lego blocks.
Awesome. So I think that's a wrap on the discussion.